Hi Year 14, the first thing that we have got to do before we talk any more about NMR is we have got to get the sample that we want to run in the NMR machine ready. Now if you look at the middle image there, you'll see that there are lots of little long tubes, and this is what the sample is placed into. Now before it's put into the little tube, it's dissolved in a deuterated solvent, and into that little tube then, as well as the sample, we will add a standard. Now we'll deal with the standard first of all. The standard that we choose for NMR is a standard called TMS. Now TMS stands for tetramethylsilane. Now on page 3 there, we've got some lines at the bottom, but it would be drawn in just beside there, this structure of the TMS. Now this TMS is given the chemical shift 0. We'll talk about chemical shifts a wee bit later on. But if we remember that this is assigned 0 ppms and all the chemical shifts then are measured relative to this. Now we've got a question at the bottom of page 3. Why do we choose this tetramethylsilane as our standard? Why do we not choose something else? Now it's got to do with this structure of tetramethylsilane. So make sure that you've drawn the structure in somewhere in the bottom half there of page 3. Now if we look at the structure, we have got one silicon atom right in the middle, and it's surrounded by 4 methyl groups. Now that's probably the most important thing. All these methyl groups are attached to the silicon, so therefore there are lots of these hydrogen atoms, a total of 12, and that means that this tetramethylsilane will give quite an intense peak. Remember, in this NMR, it's the protons that we are concerned with. Now we've really got 4 main reasons, and we've got, I think, enough space to pop in the 4 main reasons. Now if you write the first one in, the signal that this TMS gives, remember it gives a nice intense signal, is outside the range shown by most protons. We could put in brackets, it won't obscure any main signals then, so it keeps itself well out of the way. All of the hydrogen atoms and the carbons are chemically equivalent. Now we can deal with carbon-13 NMR, but we're not going to. We're going to concentrate on the hydrogen atoms. Now chemically equivalent means that they are joined to exactly the same thing. They're in exactly the same chemical environment. And if we pop into brackets, like I said, that's the reason that it produces a single intense peak. Our third reason then, there are 12 of these hydrogens, again another reason why it produces an intense peak. It's non-toxic, that means it's safe. It is inert, it doesn't react with the compound that we are analysing, and it's got a low boiling point. That means that we can distill off this standard and we can use it again and again, therefore saving a wee bit of money. So we've dealt with the standard, and remember that that goes into the sample tube along with the sample. Now, we said that when we were preparing the sample that we have got to pick a good solvent to dissolve our sample in. Now, if you turn to page 4, we've got a question in the middle of the page. Why do you think we pick a deuterated solvent? Now, if we deal with what a deuterated solvent is, it's one where the hydrogen atoms are replaced with either H2 or deuterium, and H2 and deuterium are really the same thing. So if you think about it, we've taken our solvent, we've taken all the normal, if you like, hydrogens out of the solvent, and remember we're dealing with the atoms that hydrogens in the sample are attached to, so therefore we're picking a solvent without any hydrogens that our NMR machine can pick up. And if you draw the structure of that solvent in beside the question. Now a common solvent that we use is trichloromethane. Okay, so we have got the 3 chlorines and we have got the one normal hydrogen, if you like, replaced by this H2 or this deuterium. Now the reason that H2 is not detected by the NMR machine is because it's got an even number of particles in its nucleus, and our NMR machine will only pick up hydrogens that have an uneven number. So hence it picks up H1 atoms or H1 hydrogens. Now we've got 4 lines there in the middle of page 4. We're asked the question, why do you think this deuterated solvent is used? We're going to write in, deuterium is not NMR active. We're going to write in as well, deuterated solvents are used so that you don't get a large solvent peak overpowering your molecules peak. So there are no H1 atoms to be detected by the NMR machine, and therefore there are no peaks caused by the solvent. So we've dealt with the solvent that we dissolve our sample in, and remember, into that solvent with the sample dissolved, we pop our TMS standard.